session, and I'll ask the speakers to come and sit here for the Q&A session. So our next speaker is Hamza Saeed, and he's going to talk to us about a modified state parameter for evaluating liquefiable sand containing plastic fines. So we stay in the same sort of theme, and the next speaker will be Saeed. Thanks.
Thank you very much, Professor. Good afternoon, everyone. I would like to welcome you to my presentation. In my presentation, I will mainly highlight the modified state parameter evaluation for the sands containing plastic fines, in fact, because a lot of studies have been conducted and mostly focusing on the non-plastic fines when we talk about these modified state parameter. So here is the presentation overview, and I think no need to introduce in detail because most of us know what are the basics of the liquefaction. So just some triggering mechanism, especially because most of the talks today were related with the cyclic behavior. So let's move towards the monotonic behavior, in fact. So the flow liquefaction triggers basically by monotonically increasing loads, especially one of the prime examples is from the embankment height. And it happens when the undrained effective stresses basically crosses the instability line, which is usually denoted in figure 1 as IL. And the susceptibility analysis is usually carried out, as we all know, from the water testing as a direct measurement, then from some constitutive models, and of course, from the field testings. And there are many factors involved, especially when it comes to the liquefaction and susceptibility analysis. And dominating factors are, in fact, the relative density, morphological characteristics of the sand, and the fines content, and also the stress state which are being applied to the sand. And some are the additional factors, and in fact, Professor Arya have talked in detail about the inherent fabric anisotropy on such case. And obviously, like reconstitution techniques, most of the times, in fact, different reconstitution techniques yields in different behavior. So here are some of the advantages and disadvantages listed for the 3 most common ones over here. So this is a typical undrained monotonic behavior. The curve 1 is showing the flow behavior, strain softening behavior, and then we have a limited flow where after a transition, like strain hardening starts. And the third one is obviously the non-flow behavior. And usually when it comes to the framework, critical state soil mechanics comes handy in this case. And generally it is represented as a straight line, but in fact it has, Dean and Jeffries also have defined as a bilinear. Like at high stresses, the line drops as well, like significantly. Whereas the Wang et al. Has defined it as a power function, which we can observe in the equation on the extreme right hand side. So usually this curvature occurs due to the particle crushing when the sand is subjected to the higher stresses. So in fact, the state parameter evaluation is still like a debate that does the the original state parameter, which is a function of the density parameters, the void ratios especially, by Bean and Jeffries. In fact, the stress state parameter by Klutz and Pope, they have preferred to quantify it as a stress ratios. Then Bobby et al. In 2009, they have suggested a modified modified state parameter, which is basically a function of the stress ratios. In the numerator, we can find this stress difference, and the initial divided by the initial stress applied, and also, of course, the void ratio. So it is quite, I should say, important that when it comes to the stress state parameters, that should be like the most applicable scenario in such case. So, in fact, I will not talk more about the state parameter because the next presentation is by Professor Cook. So, let's not spoil many things now in this slide. And there are some of the ranges which are defined by the Govia et al., especially when we use the modified state parameter, how the behavior will be observed. So here is the methodology of my research over here. We have collected the sand from the Famagusta Bay, and we have added the plastic fines with different proportions, and that one was sampled in the Eastern Mediterranean campus. And these are the particle size distribution of soil groups. So I have basically added 10, 20, and 30% fines into the sand. And there are also 3 different types of the plastic fines. So basically they are like highly plastic fines which are being included into the sand. So which are the highly plastic silt clay and the combination of these two, silt and clay. So we have developed a technique by the sedimentation technique, and from the original clay, we extracted these specimens. In fact, that procedure has been defined in our recently published paper. So here are some of the here are the index properties of soil. So basically, here we have the our soil sand is poorly graded, and these are the USCS classifications of the groups. And also, like here for the separated fines proportions, their specific surface area, cation exchange capacity, and their classifications as well. So here is the void ratio variations with respect to the fines content. In fact, the threshold fines content was observed at 10%, which when we compare with the literature is quite lower. So one of the main contributing factor here is that because of the higher surface charges or higher specific surface areas of the fines content, so they have occupied more of the regions. And as you can see in this optical microscope at the 100% magnification, that how these with the increase in fines content, like the sand particles are like hidden in the layers of the fines content. And we use diaphanal deposition technique as a specimen preparation method, and 2 different relative densities applied 35% and 70%. So coming towards the analysis part, and we can see that when the consolidated relative densities were calculated, with the addition of the plastic fines, it has shown much higher compressible, and the states have been completely transformed into the denser states. And we can see a variation, especially in figure number 11, when we compared with the plasticity indices, that as the PI value increased, the consolidated void ratios are also increased as well. So here are the unread monotonic behavior, and we have our sandy soil, which was in the loose state, have been completely liquefied, total flow failures, total flow liquefaction observed. And at the dense states, it was stable enough. Whereas the sand with the silty group in all 3 cases have been has shown a stable response. But interestingly, when a combination of the 10% of silt and clay together were added, it showed quite a unique behavior, especially at 50 kilopascal, it showed a limited liquefaction rate, but when the stress was increased, total flow failures occurred. But as we can see that when we compare this with the sand with the clay group, the shear stress values are quite, the deviated stress values are quite lower. So this is one of the fundamental aspects can be attributed that the clay particles which are present in this sand, they have quite created a chain network, which is basically an unsteady connector. So that's why, and if we see that equation, the shear stress equation, which is the function of the cohesion plus the effective stress within tangent of internal friction angle. So in this case, the effective stresses has reduced quite a lot. but the cohesion factor have contributed in the stability over here. Now, coming towards the effect of the fines content on critical state line, as you can see, we have quite a lot of variations, in fact, as compared to the original sand. There are three factors involved here. You can see that first, when the fines content were introduced, the shifting and rotation of the critical state lines occurred, and the first factor can be contributed towards the carbonate content which is present in the soil, and the second one is the amount of fines content, and the third one is the plasticity index. So due to the fines content, the downward shift occurred, but a threshold fines content, an upward shift has been observed. Whereas the plasticity index, as from Hisao and Pan recently published article, they have mentioned that the rotation is in such cases is due to the plasticity of the cohesive soils. And when it comes to the state parameter evaluation, as you can see that when we use the Lee and Jeffries equation, and when they have shown a quite significant values, in fact, when compared to the initial mean effective stress in the stress ratios, whereas the values have quite reduced when the modified state parameter equation was used. So in this case, the stress state or stress ratios, as mentioned by Klotz and Coop, that should be considered in this aspect. So for example, over here, the variation of the state parameter and modified state parameter along with the stress ratios is plotted. And generally, as you can see in the modified state parameter, the soil, the trend line shows that it is going to be more towards the dilated behavior. Whereas in the state parameter, it is almost becoming parallel to the x-axis, as you can observe here. So similarly, comparison between the state parameter and the modified state parameter with respect to the plasticity index and fines content is shown in this figure number 2. Moving forward. So here's like additional analysis presented here that in fact, along with the stress ratios, we have included two more factors over here, that the plasticity index fines content, especially the threshold fines content, because the threshold fines content also shows which type of particles are going to dominate, especially before threshold, it is a sand dominated region, and after threshold, it is fine dominated. So we have added these three factors as well, and the empirical relationship has been established. But as you can see here, there is quite a gap over here on the top. So because we have used some high plasticity cohesive soils, in fact, we collected some data from Sao and Pan from 2016 study. So that gap, because they have used the low plastic fines. So in fact, it is quite following the trend for these x-axis, which includes the plasticity index, or I should say the physical properties of the particles. And there are two empirical equations which can be added towards other empirical equations available in the literature. So first one is for the state parameter estimation, and the other one can be used to estimate the modified state parameter. So just I'm on the last portion of my presentation. I will just highlight some of the field observations carried out during the course of 1 year. So we have 6 test beds over here, and when we were collecting our soil samples and monitoring the groundwater table, especially after 6 months, due to the excessive rains, and there were quite a phenomenon occurred over the site. So, for example, these 2 test pits location are now completely submerged underwater. Although we can see that there is a barrier between the sea and so definitely this is not the seawater, or maybe it's a seepage from the ground. So another factor which can be contributed is that on this particular location, after the water was dried out, excessive settlements were observed on this plane of surface. And in this side, you can see the soil erosion occurred as well. So, but the question here arises that can this soil erosion also hints towards the liquefaction susceptibility or not. So to answer this question, Edgebury and ICWA in 2021, they presented an idea that the detachability and the liquefaction prediction index can be obtained. So here there are certain classifications based on the DLPI. If the scores are less than 4, so it's quite high liquefaction potential, and if the soil erosion is occurring on the site. Over here, like these are the 3 highlighted factors, especially the water, in situ water content, the porosity, and the permeability. So obviously, these are also the governing factors when we talk about the liquefaction susceptibility of a particular soil. So these are some of the conclusions, and I will conclude this presentation by we have tested the sand by incorporating different types of fines content, and obviously the loose states were more prone towards the liquefaction behavior, and the critical state lines were shifted due to the reasons I have mentioned earlier, and compared the state parameter and the modified state parameter of the groups we have analyzed. So thank you very much for your attention.
Thank you very much. So as you say, when the next presenter, so Matthew Cook, professor at University College London, is going to talk to us